Okay, I want to take the time to conduct a little extensive review on what we should know so far in this unit at this juncture. Okay. Simplify and evaluate where possible. Okay. Simplify and evaluate where possible. So we have expression with exponents, 5a to the third and then to the second, and then times 3a to the negative fourth to the second. So it's all multiplication, division. There's no division, but there's no plus or minus operators within the expression, so it's all a product. So you make 3 lines, and then you underline the expression if there's not a line. So what are your numerical bases? You have a 5, 1 factor of 5, 1 factor of 3. Then you have 2 factors of the variable a, so that just means we'll add the exponents. Okay, so 5 is to the first, but we have to distribute 2 to 1. That's 2. 3 is to the first, but we have to distribute 2 to 1, and that's 2. Now on your a factors, 2 to 3 is 6. 2 to negative 4 is negative 8. So 6 plus negative 8 is negative 2. So we have 5 to the second, 3 to the second, a to the negative second. So let's go through each factor on the next line. That has a positive exponent, you keep it where it is, 5 to the second. That has the next factor, the 3, has a positive exponent, you keep it where it is. The next factor, the a, has a negative exponent, so we move it to the bottom and then rewrite the negative exponent as positive. Okay. Now evaluate. 5 to the second is 25, and then 3 to the second is 9, and on bottom you have a to the second. Then I can still simplify this because I can take 25 times 9, that's 100. So there's your answer, 100 over a to the second. Okay, my next problem, 4x to the negative third, y to the fifth to the second. 4x to the negative third, y to the fifth to the second. So you underline the expression, and you make 3 space lines. First, what are your factors? The numerical base factor is a 4, and the variable base factor is an x and a y. Only one of each, so there'll be no adding of the exponents. Okay, 2 times 1 is 2. 2 times negative 3 is negative 6. Then 2 times 5 is 10. You really need to put a 1 on that 4, because if you don't, you're going to want to distribute 2 to 4, and that's wrong. Okay. So 4 has a positive exponent. Keep it where it's at. X has a negative exponent, so it needs to be moved down so it can be written as a positive exponent. And then y to the 10th stays where it's at. Then 4 to the second becomes 16 times y to the 10th over x to the 6th. And you can't simplify that anymore. Okay, my next problem. Okay, you've already got the fraction line, so don't make it. So let's talk about the top. We have a numerical 4. And then a variable base of a, only one of them on top, so I don't need a plus, and then a b, and then a c. Now on bottom we don't have any numerical factors, but we have an a b, and a c. Okay, so 4 is to the first, and there'll be no distributing because there's no parentheses. A is to the first, b is to the 6th, and c is to the 3rd. Now on bottom, a is to the 5th, b is to the 1st, and c is to the 3rd. Now, when you actually have stuff on the bottom, you need to see if any of the bases match so you can cross them out and subtract. So you got matching a, so you take out the one with the smaller power and then minus from the other one. 5 minus 1 is 4, so now on the bottom we have a to the 4th. Okay, b to the 6th, b to the 1st, you take out b to the 1st minus 1, and that's now b to the 5th. Okay. C to the 3rd, they're both the same, so they both are gone. Alright, so we have 4 to the first, has a positive exponent, keep it where it's at. Don't move it if the exponent's positive. B to the fifth, positive exponent, keep it where it's at. A to the fourth, don't move it to the top, okay? You keep it, positive exponent means it stays exactly in the same place it's already at. 4 to the first is 4, and then B to the fifth, A to the fourth, simplified. Okay, now the next part. Classify the polynomial function by the degree, the number of terms, and the end behavior. So here's the first function. Y equals 3x to the second minus 8x to the fourth plus 9. Y equals 3x to the second minus 8x to the fourth plus 9. First thing you need to do is write that, because this is out of order. X to the fourth should come first, and it would have a negative 8. Remember, it's negative 8. Then there's no x to the third, then x to the second, we would put the 3. There's no x, and then plus 9. Now, under it, after it's rewritten, write the two words terms and degree. Terms and degree. There are 3 terms. The degree is the highest exponent, which is 4. Okay? Now come over here and write these following things. As x, and put an arrow going to the right, approaches positive infinity, that's a sideways 8, what does y approach? And then under it write, as x approaches, an arrow to the right, negative infinity, what does y approach? Now to find the positive infinity, what y does, you write LC, leading coefficient. The leading coefficient's negative 8. Now since it's negative, y will approach negative infinity on that side. Okay? So it's negative. If that was positive 8, I would write positive infinity. As x approaches negative infinity, what does y approach? Okay? Now, what you put now is what the degree is. The degree is 4 because of the fourth power. Now that's an even degree, so the end behaviors have to be the same. Same end behavior. So if that's negative infinity, it will also do negative infinity on the other side. Same end behavior. BEV means end behavior. Okay, and then my second one of these, y equals x to the 7th power minus 2x to the 5th power minus 4x to the 3rd power minus 2x minus 1. X to the 7th minus 2x to the 5th minus 4x to the 3rd minus 2x minus 1. Okay, now these are in the proper order. X 7th, x 5th, x 3rd, x and constant. So I don't need to rewrite it like I did on the last problem. So the terms, you got 1, 2, 3, 4, 5. The degree is the highest exponent, which is 7. Now, same things. As x approaches positive infinity, what does y approach? As x approaches negative infinity, what does y approach? So on the positive infinities this way to the right, what's the graph do? Well, it depends on the leading coefficient. The leading coefficient would be 1. Now it's positive, so it'll approach positive infinity. Now, on the other side, okay, negative infinity, what does y approach? Okay, now the degree is 7, and that's odd. So then the end behaviors will be opposite end behaviors. Okay, so if that's positive infinity, this will be negative infinity. Okay. Okay, find the quotient and the remainder. You're dividing polynomials. Here's what this says. We have a parentheses and we have 2x to the 3rd plus 9x to the 2nd plus 11x plus 3. 2x to the 3rd plus 9x to the 2nd plus 11x plus 3 divided by 2x plus 3. So we have to use synthetic division. So my dividend is 2, 9, 11, and 3. Now what's the divisor? Well, we need to take the 2x plus 3, set it equal to 0, and see what we're going to divide by. So we minus 3, divide by 2, divide by 2. You can keep, I'm going to keep it negative 3 over 2. Now you could make that one a decimal because it would just be negative 1.5. Where you can't do decimals is where they go on forever or repeat. So negative 3 over 2, if you like negative 1.5 better, fine. So I carry down the 2, and then I take 2 times negative 3 over 2, negative 3. So every time I drop it, I have to times, and I just got negative 3. Now don't put it there, you put it here and add. That'd be 6. Now 6 times negative 3 over 2, negative 9. It's 2, then 2 times negative 3 over 2, and that's negative 3. Well, that's 0, so the remainder is 0. Okay, if your remainder is 0, you can forget it. Now your 2, that was x to the third, not anymore, it's x second, plus 6x plus 2, and that's the answer. Now, the next problem. Apply the rational roots theorem to find the zeros of the function, or x-intercepts of the graph. Roots, x-intercepts, solution, they mean the same thing. So zeros of the function mean set that f of x thing equal to 0. And then I like to put equals 0 over there. So it says rational roots theorem. Well, that means I find the 3 answers for x, okay, by synthetic division, okay, and RRT. You're going to find 3 answers, but you find your first by RRT, excuse me. Okay, now remember how to conduct the RRT. You know what you're going to put inside here. You're going to put 1, 5, negative 4, negative 3. But use the RRT to find out what you're going to put out here. So remember how to run the RRT test. You take the constant at the end. It doesn't matter if it's negative or positive. And then the leading coefficient, 1. Well, the only factor of 1 is 1. And the only factors of 2 are 1 and 2, because after dividing by 1, you divide by 2, but I already have 2. Now, 1 divided by 1 is 1, positive or negative. Then positive, negative 2. So we do direct substitution into the equation with these values. So you got 1 parentheses 1 to the third, plus 5 parentheses 1 to the second, minus 5 parentheses 1, minus 2. Okay, that didn't work. Now put 2 in. We have a short list of possibilities, which makes it nicer because I'm pretty sure I'll find something. 16, okay, now do your negatives. Okay, well, sorry, I need to do negative 1. I totally messed that up. Okay, I got 6, now try negative 2. Okay, something's wrong. Let me try this again. Okay, 1 worked originally. I punched in something wrong. So I put 1, that's your first answer. Now, divide. You got 1, 1 times 1 is 1. 6, 6 times 1 is 6. And then 2, 2 times 1 is 2. Remainder 0, so we cross it out. Now the 1 used to be x third, now it's x to the second. plus 6x plus 2 equals 0. So now it's a quadratic equation where I have to find two answers. So a, b, c, and apply the discriminant. B squared minus 4a and c. So b is 6, a is 1, c is 2. So 6 times itself is 36, 4 times 1 times 2 is 8. So it's going to be 28, and I don't need to do the I, okay, so I do second square root 28, and I get 5.29. Now you do the quadratic formula, then you wouldn't be able to factor because you got a decimal. So opposite of b, plus or minus the square root, b squared minus 4ac over 2a. So you're going to have negative 6. And then a is 1, 2 times 1 is 2, and that square root we just figured out, that's 5.29. And then I proceed. If I would have got a whole number there, I would set up my GCFT, but I didn't. So negative 6 plus 5.29 divided by 2, negative 0.36. Then negative 6 minus 5.29, click equals, divide by 2, and you get negative 5.65. Okay, now you could also, most people do it like that, but you could also write that, divide by 4 and 7, it'd be 2 square root 7. But if I do it that way, then I wouldn't be able, you would be able to reduce your outsides. Those could all be by 2, 1, 3, and 1. So that would be negative 3 plus 1 square root 7 if it's over 1, and then negative 3 minus 1 square root 7. You just leave them like that. So you could do it like this or like this. Most people pick like that. Okay, next one, find the roots by factoring. So set that equal to 0, then just bring 0 over here. So factoring means you're going to find the answers by your boxes. How many terms you got? You got 3. So finding 3 terms, I'd go GCF and then my table, my trinomial table. Okay, so 1, 5, and 36 would be 1, but the last term does have an x, so we put that. And then that's the first number's negative, so my GCF's negative, but it's 1x, so we need to go through with it. So we take that 1x, we put it right here, okay? So I can just ignore the rest of it, so it'd be 1x to the second minus 5x minus 36. Remember, the x's go away. Now ABC, 1 times negative 36 is negative 36, so it's a positive times a negative. We're adding to negative 5, and when I divide this by 4, I get 9. To shorten the video, I'll just go tell you, we'll just tell you what it is. And I don't need to change the signs because that would add to negative 5. Now you got to know what your a is. Your a is 1x to the second. So you can delete the 1, make 2 parentheses, then the x to the second is x times x. Plus 4 minus 9. Remember, we always bring those up here then to see if we can factor them down anymore. The one with a plus can't be factored. You bring that down. The one with a minus, your x doesn't even have a power, so how can you break that down? You can't. Okay, if it was x to the second, I'd be a different DOPS, but it's not. Okay, then we find our answers. So 1x could equal 0. Remember, we're going to have one answer from there because it's just x, there, and there. So that'll be my 3 answers. So x is 0. There's the first answer. X plus 4 equals 0. We'd minus 4. That'd be negative 4. That's your second. X minus 9 equals 0. That'd be 9. There's your third. Okay. Okay, next problem. F of x equals x to the 4th minus 20x to the 2nd plus 64. So 0 equals 0. Transition that over there. And now you find your 4 answers by factoring. okay, not with the rational roots theorem. Okay, so I've got 1, 2, 3 terms. So GCF and the table. 120 and 64 would be 1, okay? You don't have an x at the end, so it'd be 1. That's it, so delete that. Now do ABC like you would with a quadratic. It's not a quadratic equation, but I still want to take the first times the last to get 64 positive, so the signs would match. They would have to add to negative 20, so they would match as negatives. Then if I divide this by 4, I get 16, and that's it. Now what's your A? 1x to the 4th this time. Now you can still get rid of your 1, okay? So make 2 parentheses, but x to the 4th is x second, okay? So I have factored the trinomial. Now bring both those binomials up here, because there's 2, and see if you can factor. Well, that is a minus, and the x has a second power, so that'd be x times x. There's nothing in front of x that I need to put on the x's. 4 is 2 times 2, so that's adopts, okay? Okay, and then this one here has a minus, and x is to the second power, and 16 is 4 times 4, so that would be adopts. Remember, use your multiplication table, and if it's a number going this way in those bold, see diagonal, it can be rewritten times itself. It has to be a minus, and the x has to have an even power, but yeah. Okay, now, x plus 2, that's done. X minus 2, now there's a minus, but x doesn't even have a power anymore, so can't break that down. And then that's a plus. That's a minus. X doesn't even have a power though, so that's done. And those are my 4 factors. We get x is to the first power in each of our parentheses, so there's one answer from each factor. So x plus 2 could equal 0. So it'd be negative 2. X minus 2 could equal 0. So it'd be positive 2. X plus 4 could equal 0, so that would be negative 4. And x minus 4 could equal 0, so that would be positive 4. Okay, wow, that's 4 real roots. I have no i's or any of that, so yeah, kind of. Okay, then my last one. F of x equals x to the 3rd power minus 6x to the 2nd power minus 4x plus 24. So equals 0. There's 3 answers. And we have 4 terms. Okay, so 4 terms is the grouping method. And it would be factoring. I wouldn't tell you to solve it by factoring if the grouping doesn't work. Don't use the RRT unless you're told. Okay. Okay, so that's grouping. So I put 1x cubed with minus 6x squared. Then I put negative 4x with plus 24. So divide, 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 divide. That's positive, so we have positive here. That's negative, so you have negative here. Okay, x's are 1 and 6 would be 1, and you have x to the 2nd on the final term, so x second. 4 and 24, here's 4, 24 is there, so I would do 4, but not with x, because there's no x right there. So 1x second rolls out here, negative 4 rolls out here. So it's going to be 1, x third, x second, 3 minus 2 is 1, so it would be x minus 6. And this is the same thing, 1x, that's negative 6, so minus 6. Okay, the expressions match. So 1x minus 6 comes out here, and I cross them out. And that leaves me with 1x to the 2nd minus 4. Now let's bring those up here. 1x minus 6, 1x to the 2nd minus 4. At that point, you might want to delete the 1s. You really don't need those anymore. Now that has a minus, but the x doesn't have a power, so it's done. Okay, put it down here. that has a minus, and the x does have a second power, so that's x times x. 4 is 2 times 2, so that's adopts, okay? So it'll be x, 2 and 2, plus, the other one's got a minus, but the x doesn't have a power, so that's broken down as far as it can be. I have taken the original expression and now factored it. Okay, so these are the factors. You would get one answer from there because it's x to the first, one from there because it's x to the first, one from there, which will fill out my three answers. So x minus 6 equals 0. So x equals 6. X plus 2 equals 0, which gives us negative 2. Then x minus 2 equals 0, which gives me